Hello everyone, this is Srijit Jain from Xolcano Technologies, and I would welcome you all for another product review. In this video we'll be looking into the second version of XT IoT Wi-Fi development board, which is also based on Esp826612F. The contents of the presentation would involve starting from the introduction, hardware overview, features and peripherals, sample function or test run, then the applications. We are looking at the second version, or could also be called as the smaller or the cost-effective version of the XT IoT series. It fits in the dimension which are as small as 8 by 4 centimeters. Hence, the compact size and the smaller dimension makes it to be used as not only as a development board but also as the application specific one, especially where the opportunity space is the issue. Alright, now let's talk about the hardware overview and some of the peripherals on board. Okay, now starting with the microcontroller, which is Esp826612F. It has got a 32-bit low power processor clocking at the speed of 80 megahertz, and then it could also support till 160 megahertz with an onboard antenna, as we could see here. Some of the top features of this controller is it has got a 10-bit ADC, supports Wi-Fi at 2.4 gigahertz, supports WPA2 security modes, and also it enables the devices of maybe iOS or Android. And then it has got some of the general features like UART, I2C, HSPI, PWM, and other GPIOs, and many more. And one of the outstanding feature is that it has a special mode known as the standby or the sleep mode, in which it consumes as less as 1 milliwatt of power. And now moving on to the next component, which is the header for SPI communication in order to establish and serial peripheral interface with any other external devices. It's a kind of communication where a master device could control n number of slave devices. Here we have got general purpose I/O pins that are I/O0 and I/O2. These pins can also be used for flashing or programming the chip. And then we have the I2C header in order to establish the I2C communication with external modules. And the number of modules could vary from 1 till 127. And here we have got the buzzer for audio indication, and then the FUDI header in order to establish a serial communication with external devices at different voltage levels like 3.3 or 5 volts. Alright, now moving on to one of the important feature, that is USB micro support backed by CH340C. To talk about CH340, it's basically a bus converter chip which enables the USB signals to be converted to serial signals and vice versa. With this, one can achieve a direct programming of the chip. And then we have two LED indications for two MOSFETs, which are rated at 30 amps DC, and the voltage support is from 0 to 20 volts. And both of these MOSFETs are isolated through opto-isolator circuit, and these are the MOSFET outputs. And here we have an onboard power supply of 3.3 volt for any external uses. In the same way, we have got 5 volt and ground for any external uses. Here we could place a push button or a switch in order to control the input. And then we have a reset button which performs a full system reset on clicking it. And finally we have the ADC input or the ADC header in order to sense any analog signal from any external sources. So this was all about the overview of the hardware and all about the peripherals or features on board. Alright, now let's do the test run and check the functionality of the board. Once the board is been powered up, the green light, which is constant, indicates the power supply to the board. And here we have uploaded a simple program to blink two LEDs with 1 second of delay apart. Alright, let's move on to the applications now. There are numerous amount of applications of this device. Some of the popular among them are home automation. Here we'll be controlling the appliances, devices within the home or house, like fans, lights, gates, pet feeders, etc. It can also be interfaced with the Blink platform, which is being shown already in the previous video. Here we have the MathWorks ThinkSpeak, which gives us the insight of sensor data in terms of visual or graphical representation. The same goes with the Adafruit IO, except we can control the app here. It can also be used with Google Firebase, where the data can be stored in the Google Cloud Platform, where it can be used for for performing any analytics or accessing the data from anywhere around the world. This device supports IFTTT, where are simply known as if this then that. This is the platform which provides the kind of service where the user could program response to an event in the real time, just like getting lifetime notification on the device or on the mobile itself or so. It also supports Node-RED, which is a flow-based online tool where the hardware devices will be wired together programmatically in terms of nodes, which could be operated in many interesting ways. It also supports Arduino Cloud IoT platform and the voice assistant, which is one of the most popular platform where the voice control is used to control the applications. Google Assistant, Alexa, Siri are some of the best examples for this. So this was all about the overview of XT IoT version 2 board. Thank you all.